China didn't announce a discovery. It didn't brief the press or tease the scientific community with a cryptic statement. Instead, it did something far quieter and far more unsettling. Late one evening, with no build-up or ceremony, a cluster of FITS files, astrometric logs and photometric sequences appeared on a government server, tucked neatly into the China Virtual Observatory archives. To the untrained eye, they looked routine like any other batch of nightly sky scans. But the astronomers who opened them quickly realized they were looking at something else entirely. A set of observations made during the precise 36 hours when Western astronomy inexplicably went blind. And what those Chinese files revealed didn't just fill a data gap. They challenged the entire timeline of what we thought we knew about 3I Atlas. Only the third confirmed interstellar visitor in human history. From the moment the object was detected on July 1, 2025 by the Atlas survey in Chile, astronomers sensed something was off. Interstellar objects are unusual by definition, but this one was more than unusual. It was fast. Too fast. Calculations placed it at heliocentric speeds approaching 209,000 kilometers per hour, barreling through the solar system on an arc that clearly originated beyond the sun's gravitational influence. Major observatories across the West rushed to track it, coordinating an almost continuous observational network. Hubble locked on. JWST calibrated its instruments. The VT and Gemini telescopes scheduled overlapping exposures. It was a global effort to capture an interstellar messenger in unprecedented detail. And then at the worst possible moment, the sky went dark. Not because of weather or technical failure, but because of scheduling. 5 of the most sophisticated observatories on Earth entered maintenance, recalibration, or instrument swap cycles within the same narrow window. Gyroscopes were realigned. Mirrors were cleaned. Detectors were cooled and swapped out. It was all routine on paper, mundane even, but strangely synchronized. In that 36-hour blackout, 3I Atlas entered a phase astronomers had been waiting for. The moment a comet or comet-like object nears the heat of the sun and begins to reveal its true nature, jets activate, comas bloom, dust and gas ratios shift. The internal structure is laid bare by sunlight. It is the closest thing to an X-ray a comet ever gets. But as the West looked away, China kept its eyes wide open. High-altitude observatories in Tibet, Qinghai, and Yunnan were still operating, still tracking, still taking exposures under cold, stable skies. Their instruments didn't go offline. Their detectors didn't cycle down. Their scheduling didn't shift. While the world's premier telescopes slept, China watched the object in continuous detail, capturing every minute of the crucial phase the West missed. And that uninterrupted record, those quietly uploaded FITS files, painted a picture that defied every model of natural comet behavior. The coma didn't simply expand outward as sublimating ices typically do. Instead, it stretched sunward toward the very heat that should have been tearing the object apart. The tail elongated at a speed that contradicted earlier measurements, as if responding to a change in internal configuration rather than solar wind alone. The brightness didn't pulse with random fluctuations. It surged by nearly a third of a magnitude in a matter of hours, then stabilized as though following some internal regulation. Dust profiles shifted sharply toward large carbon-rich grains, an unexpected composition for an object with the thermal history inferred from pre-blackout data. To Western astronomers accustomed to the chaotic physics of comet outgassing, this behavior looked far too orderly. To understand why the data struck such a nerve, one has to understand what a coma is. A natural comet's coma is simply a cloud of gas and dust released as solar heat wakes the nucleus. It is messy, turbulent, irregular. But the coma captured in China's data did not look like a chaotic cloud. It looked like a coordinated response, a structured rearrangement that occurred precisely when only one nation's telescopes were watching. Before the blackout, JWST and Sphere X had already taken note of the comet's unusual chemistry, a carbon dioxide-dominated coma instead of the water-driven behavior expected from most comets. That alone hinted at a very different thermal past. But during the blackout something else happened. China recorded what researchers are now calling an echo signal. A sudden brightness spike followed by a symmetrical expansion wave moving through the dust cloud like a ripple. It wasn't drifting, it was reacting. When Western observatories came back online, the object had moved more than 1 million km, enough to disrupt continuity in any model attempting to reconstruct the missing hours. But China's data stitched the timeline seamlessly, allowing researchers to align pre-blackout and post-blackout observations with millisecond precision. And once aligned, the merged datasets pointed to a conclusion more troubling than any scientist expected. 3I Atlas was not acting like a passive interstellar comet. It was acting like an object whose behavior changed in direct response to solar energy. Every photon captured by China's observatories underwent careful calibration through nitrogen-cooled detectors, atmospheric corrections, redundancy servers, and Gaia-anchored astrometric checks. The resulting sequences formed the first uninterrupted photometric record of an interstellar object during its peak solar activation. They showed a sunward coma elongation inconsistent with standard sublimation, brightening patterns that matched jet activation rather than melting ice, dust-to-gas ratios incompatible with the object's estimated size, and orbital refinements that reduced uncertainty by a factor of 5. If the object were purely natural, every element of the behavior should have been chaotic. Instead, the data showed coherence. When astronomers around the world downloaded the Chinese files before any official interpretation was released, the silence in Western institutions grew impossible to ignore. The Minor Planet Center quickly recalculated the orbit. American and European teams ran their own photometry. The hyperbolic trajectory held, but the coma's sudden asymmetry during the blackout hours did not match any established model of natural behavior. It wasn't noise. It wasn't error. It was directional. The tail geometry shifted in a way that suggested a structural change within the object. A change triggered during the period when only one side of the planet had eyes on it. As the combined data from China JWST Sphere X, Hubble Gaia DR3, and ground-based observatories were layered together, something extraordinary happened. The pieces fit too well. The spectral readings aligned with the brightness curve. The coma geometry matched the dust distribution. The orbital refinements supported the nucleus size constraints. In a purely natural system, each data set should carry its own quirks, its own irregularities. Instead, they merged into a single coherent timeline, revealing a pattern of behavior that should have been possible for a simple interstellar rock. The inconsistencies piled up. The object responded faster to solar radiation than any known comet. Its tail structure shifted during the blackout in a way that suggested active regulation rather than passive physics. Its dust profile changed in a manner inconsistent with its projected chemical history. And the nucleus appeared too small, far too small to produce the observed coma through natural mechanisms alone. Each anomaly could be debated individually, but together they painted a picture of an object that was not merely drifting through the solar system, but responding to it. Crucially, China's observations did not claim extraterrestrial technology or intelligent control. The raw data offered no such speculation. But by revealing what Western observatories missed, they forced the scientific community to confront a possibility many had quietly avoided. That 3 Atlas behaves differently depending on when and how it is observed. During coordinated observation windows, its behavior appeared largely consistent with natural models, if unusually energetic. During the blackout, when the global watch briefly faltered, the object changed its structure, its brightness, its dust composition, and its trajectory with uncanny precision. No one is suggesting deliberate communication. Yet many now argue that the object's behavior resembles a system more than a rock. A system capable of internal adjustments, reactive processes, or mechanisms that mimic activation sequences. It is not that the object is intelligent in the way life is intelligent. It is that its behavior is coherent, structured, and responsive in a way no inert body should exhibit. The dread emerging within the scientific community has nothing to do with invasion fantasies or science fiction tropes. It comes from the uncomfortable notion that we are studying something that does not behave like an object at all. Comets do not time their structural changes to match gaps in global observation. They do not brighten during the exact window when only one country has instruments pointed at them. They do not alter dust composition exclusively during unobserved intervals. They do not adjust tail geometry in a way that mirrors a reaction, not a meltdown. They do not act like mechanisms following instructions encoded deep within their material structure. And yet, 3 Atlas did all of those things quietly, precisely, and only when the world wasn't watching. As the object continues on its hyperbolic departure path, leaving the inner solar system behind, the implications remain unsettled. China's data did not expose a threat, nor did they confirm alien design. What they revealed was something equally profound. An interstellar object capable of behavior that suggests purpose. A kind of intent embedded not in biology but in process. Whether that intent is ancient, passive, benign, or simply the product of physics we do not yet understand is still an open question. But intent of any kind changes the way humanity must think about interstellar objects. In the end, what shook the scientific world was not the images themselves or the brightness spikes or the anomalous dust behavior. It was the silence that followed. The silence in the West and the quiet certainty in the East. China did not accuse. It did not speculate. It simply released the data. And the data told a story the rest of the world had not seen. We detected more than an interstellar object. We detected an interstellar event, one that unfolded differently depending on who was watching. One that changed its behavior during the one moment the global network blinked. Whether the object was reacting to sunlight alone or to something deeper within its structure, the message was the same. The universe was paying attention, and it seemed to know exactly when we weren't,